All right, it says that the stream is live. So we'll just wait a little bit and make sure everybody gets to where they need to be. And everybody's coming in slowly.
Okay.
Wait for the doors to open.
Can you make out the numbers on that screen, or is it
Hmm,
too steep of an angle?
too steep of an angle. I can't see.
Let me
I can't
try
see the
to
numbers.
find a. Tell me when you can.
They're very tiny.
Okay, but just
And
something you can see that something's happening.
yes, I can see that something is happening.
What about at that angle? Yeah.
Yep,
Okay.
we can see something's going on for sure.
Like that.
Yep, that's perfect.
Okay.
Perfect.
See, with the tall things in front of me, I gotta like go through an
Oh, you
opening.
have to look. Yeah,
Over here.
yeah.
We centered.
We are good. We are good to go.
Good.
Yeah, and I think we have some people joining us in for a bit. So they are ready because they want to build a mini lab. Who doesn't?
Right. Right.
So I know we started off this entire series with the Saudi Arabia region and building Greece analysis and awareness in that region, but it's grown so much, and Greece analysis, I think it should be global. It always has to be global because you need to use Greece for every single thing.
Yeah.
So we're taking this global, we're taking it international, and Rich is gonna definitely show us because he has everything set up today about how we could actually build a mini lab. Now, he has everything in one place. Like I know some people may need a little more space than that, but just for demonstration purposes this morning, we're gonna try to, make everything in one and give
Yeah.
you like that very good insight that you may not get to see on a very regular basis about how these things actually work and how you could use them.
Hmm.
Because those those pieces of equipment are very vital, extremely.
While you're waiting for that, let me grab another. I see how I can do a demo here, which will be
Ah,
pretty cool. So let me grab a couple of pieces that'll support that.
oh yes, definitely. Because I know that we have a lot of people joining us in. I think we have Ahmed joining us in. I think Gary's here. A couple more people are just showing up to the party, but Rich is definitely gonna take us through a couple of things, and he's gonna do a demo, which is always great for him to do. And we'll get to see how to use some of these pieces of equipment because, as you know, with grease analysis, we always want to make sure that we understand what's going on the inside of the equipment. Like, do we have degradation? Do we have oxidation? Do we have any kind of wear metals on the inside? Because all of these things are very important. But Rich is going to show us like what pieces of equipment we need to use to actually get that information, and getting that while you're on the site can help in terms of reducing some of your downtime as well. So the quicker you get that information, the absolutely the better for you. So I know we want to do like a quick demo with all of our pieces of equipment, but I'm gonna pass it over to Rich to take us through how do we actually build a mini lab. Because I'm thinking if I have enough space here, I could build a mini lab too. But
Well, thank you, Sanya. Have you checked YouTube to make sure that that's on
yes, it
and
is.
record? So we're definitely recording at that point, which is great because the entire Grease Thief YouTube channel, it kind of
Yeah,
has the history of all these,
it
and
does.
we want to add this to it. So that'll be great.
Perfect.
So I'll at least start with my head in the frame here. So it's this challenge of let's put it all in one spot and
Hmm.
then put me in a spot where you can see me as I'm talking. But what I want to do today is walk through the instruments that we've kind of nominated as the key elements of a mini lab. So
Mhm.
a mini lab should be thought of as, you've got full service labs out there, right? You take a sample, could be an oil sample, hydraulic fluid, even a grease sample. You send that on, you freight it out or ship it out rather, and get it to the lab, and then they have all the instruments they need. In fact, I'm
Mhm.
sitting in a lab today. I'm sitting in MRG's York location
Mhm.
for this demo, but I've reduced the world to this small space in front of me. So, and believe it or not, this attractive table is actually shipping container for a
Oh
full
wow.
laboratory grease thief analyzer. And
Okay.
yeah, so it's hiding under here, but it was at the right height, the right space. And I think
Yeah.
this, when you say like, well, where could I build a mini lab?
Mhm.
If I don't have a laboratory,
Yeah.
what do I need? And sometimes with the tests that we include would require some solvents or things
Mhm.
like that. And now, in many settings, you're now up against: do I need a fume hood? How do I control
Mhm.
these things? We've designed this mini lab for greases to not require any of that. So
Good.
basically, you could fit it on your desktop. Well, it's my
Right.
desktop. It's too cluttered, and and there's no room for any of this. But a clean desk, a table is really all you need for the space. And we're going to
Okay.
show you how to do some tests that don't require solvents, don't require
Good.
special power. Okay, this is
Mhm.
all here in the U.S. We're using 120 volt
Right.
as kind of our base, and that's what these are configured for. And in different areas, you'll have similar what we consider
Yeah.
low volt house voltage, let's say, and we have adapters for things. But
Mhm.
everything you see here is running off of either batteries or it's plugged in, and it's just using that simple house level current. Um, so let's start by thinking about now, what are we going to be testing? And what I have here is one of the sleeves that someone has used to take a sample using the Grease Thief sample kits, and they've sent that to our lab. And so, from here you can open this up, and this one's actually completely sealed,
Good.
um, but it does have a Ziploc on it.
Yes.
And just for demonstration purposes, we took a used sample and dropped it into one of these. But of course, by the time you take the sample, you've already opened that up, that seal,
Mhm.
and you've then resealed it using the Ziploc. So here's one of the grease thieves in a protective tube, a shipping tube that we get it to the lab, and now we can start thinking about doing the analysis here. So inside, I'm looking here, and it's pretty full. I see maybe an
Yeah.
air bubble here and there, but it looks like someone's done a fairly good job at getting us that target of slightly more than 1 gram of grease for
That's
doing
good.
analysis. So where do we start with all this? Well, I have a standard here. This is a standard grease thief, and this one particular, I can drop in and I can check the output of the FerroQ. That's the Poseidon
Right.
product. We worked with Poseidon on this to make sure that we were going to get consistent results regardless of the distribution of particulate in grease. And you and I
Mhm.
have talked about this
Oh
before, that
yeah.
that's a big difference between grease and oil. Oil, you're shaking that bottle up. You're
Yep.
distributing that particulate, whatever it is, so that it's even, and then you're taking a portion of that, presenting that as representative. But you can't do
Mhm.
that with grease.
No.
Grease is, even when we target,
Different.
yeah, it's just it's going to be what we call heterogeneous. So
Mhm.
you have to have a device that is able to measure that distribution. So as I move forward to see this, I'm going to drop my sample in here. I haven't even looked at it yet, so I don't know what we're dealing with. And right off the bat, if you can't see it, that says 4,424 ppm.
Oh
So there's some
boy.
decent, yeah, there's some decent metallic particulate in here. Now, we can't come from a place of knowing about oil analysis and put our judgments on grease, because the reason
Uh-huh.
is that oil is it's as oil is in service, there's a rate of particulate being generated, wear
Mhm.
part particulate, and then over time that oil is flowing through filters. It's
Right.
going to a reservoir. It gives the things a chance to settle out. and sometimes real big particles get smashed up by gears and
Yes.
bearings and they become smaller. So that ultimately, even though you have this kind of steady rate of wear being generated, it hits what we call like an equilibrium particle
Yep.
concentration. All those particle generation, ingression rates, the pluses, are then offset by the minuses. Okay, not
Right.
completely offset, because maybe slowly over time you would see that value go on. Grease is different, because we
Yeah.
put fresh grease into a bearing, and then as that is, rotating, moving, it's generating wear particles. Where
Right.
do they go? There's no filtration.
Yeah, they
There,
stay.
there's no opportunity to settle out. So it's
Uh-huh.
cumulative. So depending on how long this grease has been in service and what type of
Mm-hmm.
bearing it is, the 4,000 figure might actually be what we expect for that. So again,
Right.
we can't just take the expectations and the limits that we set for oil and say, wow, I'm used to seeing under 100 ppm, this must be a mess. No, it has to be relative to the expected particulate generation rate due to wear over the life of that grease until it gets
Mm-hmm.
replenished and kind of reset to zero or near zero.
Yeah.
So 4,000 ppm, that's something significant. But there's another tool on this bench that I'm going to go over and use next. And sometimes you can get it to stand up. You don't have to. We put it on its side here. And now what we have is the scale. And the
Right.
scale is going to weigh that out. So we know from what we call the tear value, like how much is an empty grease thief with a cap on it.
Right.
And we subtract that from the values on that mass device, and then we normalize the results. This
Yeah.
says 4,400, but if it's less than a gram of grease in here, that's going to be plussed up by the
Mm-hmm.
normalization. We're going to divide that fraction of or we're going to divide that result by that fraction of a gram of grease
Right.
to get it. What would it be if it was really full? And so
Mm-hmm.
those two devices are going to come in handy. A lot of times people have balances like this already
Mm-hmm.
available, so they can use that, or they just purchase a reasonably priced, accurate, calibratable balance for this purpose.
Yeah.
So we're doing that offset calculation. We're coming up with an actual ppm value
Mm-hmm.
based off of the mass normalization. So what do we have? Where do we go from there? Well, the next step can be to use our grease thief colorimeter. And
Yes.
the color is really it's helpful. It tells us
Mm-hmm.
relative to what the new grease looks like, what do we have here? And anybody who's worked around machinery knows that when grease begins to age, it does change color. It
Yep.
gets darker over time. But how dark is too dark, or
Yeah.
how much is unexpected? Or if you put in a red grease, why is it changing to purple? Right. So we
Mm.
can see these kind of things that are indicative of contamination, or the wrong grease being put in, or just the maybe accelerated aging of the grease.
Right.
So let me show this one next. So a couple components here for this colorimeter, and we have it on a platform that allows us to position this disc. This is a Teflon disc
Ah.
that you see right here.
Okay.
And what we're doing is we're squeezing it down onto this flat surface that has a window in
Mm-hmm.
the center. And this
Nice.
is the spectrometer. Believe it or not,
Okay.
this is
Wow.
a battery
Very.
operated spectrometer. So
That's
if you're
cool.
looking at this, and I think we'll be able to show this on screen, I'm going to connect to it with a Bluetooth, which is my iPhone here. And then I'm going to say scan that.
Oh,
You
yes.
saw the light
Okay.
come on. So
It
what that
did. Yeah.
what that's doing is creating a light path that's looking for something to reflect back into the
Right.
sensor. And so right now, my reading is it shows black. And the reason it
Right.
shows black is because there was no return signal of
Yeah.
that light. So what we do is we use this device, and we also want to be able to control the path length or the
Yeah.
thickness of grease that the light is going through. Now, this is related to something called the Beer-Lambert law. The
Mm-hmm.
Beer-Lambert law says that as you increase the concentration of a material in a fluid, and then you pass light through it, that attenuation of that light is going to be proportional to the concentration that's there. So what
Right.
are we trying to do? We're trying to determine Are the contaminants present? Is there other colored grease
Yes.
or contaminants? And then maybe it's even just an accumulation of wear or what have you
Mm-hmm.
that causes it to be much darker than when it's new. So we would do this with the baseline greases. So I set up my mini lab. I'm going to
Yeah.
grab the 5, 6 greases that I want to be testing, whatever I'm using at that facility, and run them in the way that I'm going to show you with this in-service sample. This spectrometer has an adapter on it. It has that window. It's a flat surface, and upon that flat surface, I'm going to take the grease in the grease thief, and I'm just going to dab it on there. So that means I'm going to
Ah,
take
okay.
take the grease thief, I pull that cap off, and I put it on top, and I push down on that piston
Right.
so that I just get a little dab on the end. Now, I may have to come closer to the camera to show this. Yeah, I don't know if
Uh,
you can see that.
I could see the dab on
Right.
it. Yep.
So I put that dab of grease on, and already, if you knew that this was a grease that when it's new and fresh is bright red like your shirt
It's
today,
not yet.
it's not anymore. But I mean, we might just say, yeah, that's brown or that's
Yeah.
black or it's a lot darker than it was. But now I'm going to take this, move it into this position, and it's resting on uh, a block, okay? And that
Okay.
block is a spacer. And
Right.
I'm pointing to it right here. So the way we set this device up is we use a number of spacers that are available for this that are
Mm-hmm.
at different thicknesses.
Good.
And there's adjustment on the side here. Let me just pivot this. There's an adjustment here with 2 cap screws. And I use a hex adjustment to loosen them with the reference block. The reference block is going to set my 0. Now this whole thing is free to move up and down. I set it to 0 at the full bottom area of travel. So when it goes to the full down position, that's when I'm going to set as 0. Then I take that spacer out,
Oh,
put this spacer in, and it sets a standard gap width because this spacer is smaller than or thinner than the calibration block.
right.
And right now, what I have in is the A block and the A block. Or okay, so actually it's the D block. So the A block is my reference. That's my
Uh-huh.
0. The D block gives me, and they're stamped right on here, gives me 35 thousandths of an inch.
Oh,
And
okay.
35 thousandths of an inch is pretty close to a millimeter. Okay.
Mm-hmm.
So that's what we're looking at. So these are thick. That's a thick gap. I also have 2 other blocks, and one takes it down to 10 thousandths of an inch,
Oh,
the other down to 5.
okay.
So what's that all about? Well, what we find is that when you get certain greases, as they get darker, if you have too thick of a path length, all that light you're introducing doesn't really come back, so it just goes
Yes.
black.
Okay.
And if you've ever taken some used grease or even certain types of grease that are dyed but just start fairly dark, and you
Mm-hmm.
smear them on a white piece of paper, you see that as it gets thinner and thinner, more color is apparent.
Yes.
Okay, so that's what we're doing here. We're giving ourselves the ability to adjust that path length on
Mm-hmm.
this device in case the first measurement that we make is just too wide and there's too much attenuation. We take it down from the 35 to the 10
Right.
thousandths of an inch. Sometimes I get confused. I say micron, but it's thousandths of an inch. So here I go. I take this down, and I take it down to its full bottom of travel. Then I
Right.
go back to the
Your Bluetooth.
my Bluetooth, and probably on screen it looks black or something,
Yes.
but it's actually a reddish brown.
Ah,
And
okay.
when we get that, that sometimes, now this is what happens if our grease is sticky. You see my
Yeah.
spectrometer rode up with it, so I
Yep.
put it down in case here. But this actually gives me a number of different values to work with. Okay,
Oh,
I've
I
got
can see some things.
RGB values. I've got
Yeah.
CIE values, and we're going to work with
Oh, those are
CIE
perfect.
values. Does that ring a bell? The
Oh, of course
CIE?
it does.
So tell us what that is.
Yeah, all about the color, all about different intensities of the color. And this
Yeah.
is linked back to a scientific chart. So it's not like we're just making up different colors.
Yes.
So that is what standardizes it. That's what gives us what we want to look and what we want to work with. So that is an important one.
And where might our viewers be familiar with using that color
Oh,
scale?
they may be familiar with it from the MPC test,
It
which we
is.
use for oil and houses.
That's correct. Okay, so in that case, we're using the same measurement system to
Hmm.
look at changes in appearance of what started out as a white patch,
Yep.
right? Because we want to see the accumulation of varnish on that white patch. So we look at the color bodies, we see how much that
Yeah.
changes. Sometimes it's very faint, sometimes it's a maybe
Yes.
yellowish color to a caramel to a brown, and sometimes it's downright
All
black.
the
And,
way.
and,
Yeah.
and at that point, you've got a lot of nasty things
Yes.
accumulated in your oil. So we're looking at it the same way. It's not quite the same. The
Hmm.
mechanisms aren't the same, but when grease ages, you
Yeah.
will see those color changes. When
Yep.
contaminants accumulate in grease, you will see those
You see
color
it.
changes. So we can see both, and if we remember the values that the CIE gives us, we got the delta E, right? And that's what
Yep.
we use. But then there's
Hmm.
also three different parameters that are related to
Uh-huh.
that, which are L star, A star, and B star. A star and B star are related to the hue or color of
Hmm.
of what we're looking at, and it looks at kind of it in the red, blue, yellow. I forget what the fourth color is, but they have it broken down into four colors, and you're basically getting kind of a vector representation of which colors represent this. And then the L star is the darkness versus lightness.
Yes.
So you can have a red grease that just gets dark over time,
Hmm.
and you'll see the L star values change, but maybe not much budging on the A and B star. And now that's my grease. It just got
Hmm.
darker with
Yep.
time. But if it starts to migrate from the red vector over to the purple vector or blue and
Yep.
red, now you know that there's a different color that's been introduced. And that's really helpful when we have multiple colored greases in
Yes.
our facility and we want to be able to pick up that color variation. So
Hmm.
we have it as a result of that test. And I want to show something else with this. You were able to see my screen decently there?
Decent. I could see the diamond for
Yeah.
sure, but it's a little bit difficult to make out the text.
Well, let me change the diamond up because
Yeah.
this software, and it's all Bluetooth to the
Oh,
spectrometer that's
wow.
down
Good.
here. Let me see if I can. Yeah, there's going to be a different setting here, which is a compare setting. And can you
Ah.
see the diamond? It's just lines now. But
No, I can't really
okay,
see it as
there's
well.
there's now two halves to it. So
Okay.
I'm going to click on one half, and I'm going to bring up a saved color, and then I have a library of
Ah,
all these different greases. And I say,
right.
okay, I know what this is. This is this particular grease,
Mm-hmm.
which
So we
is
could compare.
and now you've got that's
Ah,
the
okay,
appearance
now
of
I
my
see
new
it.
grease. Okay. And then for the other one, I'll just go back, I'll run this again. I'll hit scan with Nix Pro, and I put this down into the
Make
closed
sure.
position again. I scan it, and it produces that
Ah,
output. Now, what you have is the new grease there on I guess that's our left,
yeah,
and
left,
then the sample on the right. And it's pretty
right.
obvious the difference there, right? We can see
Yes,
that visually, and this is something that can be helpful putting into a report or
yes, it
emailing a
would be.
screenshot of this on to somebody saying, "Whoa, we've got
We have
unexpected response
changes.
here." And right below it, there's delta values. So the delta
Right.
E for this is 28.7.
Ooh, oh
That's just
boy.
remember when we do delta E the for the MPC testing,
Mm-hmm.
it's relative to the white patch, right? So we're saying
Yes,
how
it
dark has it
is.
gotten. Here, it's a delta between the new grease that's in our
Ah,
library and this grease, which is coming from a machine that's using that. So,
that's
so
interesting.
delta 28.7, that's more than just a little bit of a
Yeah,
color change that we
that's a
expect.
lot.
It's
Yeah.
quite a bit. We might be content with it, changing mostly in the L star values and a delta E of let's say 10 to 15, something
Right.
like that. But you're getting up close to 30 here, and this is something that's you're probably going to wonder. Should I have let the grease go that long? What other
Uh-huh.
color bodies are getting in there? Is the grease degrading and oxidizing? It doesn't answer all of those questions, but it flags it. And it says,
Yes.
this is a sample that we need to investigate further. And if we think about the idea of having a mini lab, that's really what we want to do. We
Yep.
know that the laboratory is still going to come into play and help us at some point. But do we have to ship every single sample
Yes.
out? Because what do you see? You send 100 samples to a laboratory, depending on how good your program is, something like 80 to 90% are probably going to come back and say, yeah, it looks okay, sample
Yes.
again, and no further analysis done. How would it help us if we could hold on to those 9 out of 10
Yes.
samples and just send the 10th one and know
Yeah.
which one it is in the group that we send on? It's going to reduce the time and the
Mm-hmm.
logistics about getting it out, the
Yeah.
cost associated with shipping, the time delay,
Yes.
because almost
Definitely.
immediately here in the plant, we've got some answers about it looks good or no. We're diving deeper on this and
Yep.
we're doing some additional analysis. So in my mind, we would work with one of the laboratories around the world that's using the
Mm-hmm.
grease thief analyzer. Do you remember where I said they were on a previous
Oh boy, I
call?
know I have there are 5 locations.
Okay.
I
Any of the
know.
any of the US ones?
I remember
Stay in
the
our let's stay in our hemisphere for a minute. Let's see how many you
yeah. Oh boy, how many do I remember? Oh, yikes! Today, I know that there were about two.
okay.
Was that SGS?
Yes, you're exactly right.
Oh,
SGS.
okay. My brain is still working. Great,
Yes,
perfect.
SGS in Vallejo. Of course, SGS is
Right.
a huge company with
Yes.
labs all over the place. Their laboratory in Vallejo, California, was the first laboratory to
Ah,
purchase the grease thief analyzer outside of us at MRG. I'll
nice.
give you a hint. There's one in Indianapolis.
God, is that Bureau Veritas?
No, it is Polaris.
Polaris. Yes,
Yes.
yes. Oh
Yes, our
yeah.
friends over at Polaris in Indianapolis have a grease thief analyzer.
Nice.
And of course, in York, Pennsylvania,
Yeah, we should have
MRG
one there in
Labs.
MRG Labs.
Yep.
Yeah.
So those are the three in the US. We have one in Canada.
Right.
That's at the ExxonMobil lab in Sarnia, Ontario.
Nice.
Okay. And remember any of the countries overseas that we have?
Oh boy, I'm not that good.
Well, let's start with
I
Poland. Okay.
yeah. Oh, I know these guys.
Yeah,
Ecol.
it is Ecol. Ecol
Yes, yes.
Labs.
They're
Yep, our
great.
friends there in Poland. I got to visit them earlier this
Yes.
year, which was great.
Yes.
They're
Watch out.
like the newest. They're like the newest addition to the Grease Thief family. So
Nice.
they got that about a year ago or a little more than a year
Good.
ago. We also have Spain. You
Yeah.
already guessed this
Oh,
lab.
Bureau Veritas.
That's
Yes.
Bureau
I
Veritas.
know they went in there somewhere.
Yeah. So up in Ibar, Spain, they have that there, and then there is. Let me make sure I don't forget anybody. There's one more in Asia,
Right.
and that's Running Land Labs.
Okay.
Okay, our friend David Shao and his team at Running Land Labs in Shanghai, they also have the
Yes.
Brace Thief Analyzer. So we got them around the
Uh-huh.
world. And so when someone says, I want to start doing the grease analysis and I want a mini lab to screen through it, where do I send the ones that fail? Like that grease
Yeah.
that we just tested had that high value on delta E for colorimetry.
Yep.
We would want to then follow that up and send it to one of those laboratories.
Definitely.
Yeah.
Because you want to
So
know what's going on.
that's right. So I've showed two of the tools in the mini lab, and I'm ready now to show the third and final grease analysis tool. That this is, I believe, the first demonstration, and so it's always a risk of going
Yes.
live with this stuff, right? And I think
Always.
some people probably prepare a lot better than me, and I'm just going to wing it. So this, if you haven't seen it before, is the substrate that we
Oh.
use to analyze greases in the Grease Thief Analyzer. This substrate is plastic. It has
Mm-hmm.
two layers. This is the back side of it, and there's
Right.
some cutouts here, and that's just the backing layer. Then here is the front layer, which is a thinner plastic, and it's broken into sections, so we have little cuts along here.
Ah.
So I'm going to feed that into what is our next instrument, and if that's the Grease Thief Analyzer, this is the GTA Mini.
Ah. Okay. Good.
So I'm introducing the world to the GTA Mini
Nice.
as a tool to complement the Mini Lab. And I'm going to stick with this sample. And I think this is an
Right.
important thing to consider. When we're screening grease samples and we find out which ones are a problem, we don't want to have to go back and say, oh,
Go
we
and
want
take
more
another
analysis,
sample.
go
Yeah.
take another sample. because any of us who do that in the field, we know that
No, it's not going
it's
to be
not as easy
safe.
as it sounds, right? It's a it's timing, it's being around the equipment,
Mm-hmm.
it may have been open at the time. So that little dab that went on our spectrometer over here has barely dented the 1 gram of
Right.
grease in a grease thief. So we're still good to go. And what I'll do now is I'll remove the plastic cap again. You saw me put it back on after I
Yep.
put it on the spectrometer
Mm-hmm.
because we want to
Minimize
protect that.
contamination. Yeah.
That's correct. And then now I'm going to take this, and this is the dye. This is the extrusion dye.
Uh,
So all those labs we just talked about, they have the grease thief analyzer and the capability of using the dye on the submitted grease samples, and it threads right on to the end.
nice.
Yeah. I mean, early on when we designed the grease thief itself for sampling purposes, we thought, what's a reasonable amount to ask for?
Mm,
You know,
yeah.
because there's a lot of critical bearings that are fairly
Yes.
small, and the amount of grease is also quite small. So if
Yeah.
you're a laboratory and you're saying send us 20 grams, 30
Too much.
grams, an oil
That's all it
sample
is.
bottle for a full, because if you fill an oil sample bottle, you're talking about
Wow. That's a lot.
150, almost 200 grams of grease.
Yeah.
Here's 1 gram of grease.
Yeah.
And it's a reasonable ask. But then we have to be able to say, what do you do with it?
Yep.
How do you get all the different tests you want out of this 1 gram? So
Mm-hmm.
part of that has always been in the grease thief analyzer, but now with the GTA Mini, we've got something that we can do in the field as well. So there's two parts to this. There's a pre-purge part, and so let me just show you the mechanism here. Um,
Okay.
this is like our starting,
Oh,
okay, and
yeah.
a couple things are happening here. You've got a an area that is going down here, and you can see
Uh-huh.
that by this block, and that's going to be pushing on the handle of the grease thief,
Yeah.
forcing the grease through that die and out the other side. For this particular one, we can't quite use the entire um, volume of it, so there is a pre-purge here. And let's see. This is again the risk of starting starting on the fly. But so when it's all the way up in that full position, it we don't get the full travel here. So what happens is it's going to push this down a little bit and start to run it through that die. And I
Okay.
don't know if you can see that, but the grease is already traveling in a channel
Yes.
towards
A
the
little
exit
bit.
here, and so we can kind of pre-position it that way. And here I even need to push a little more through to get her started, and it's almost there. When I get it down to that position, okay, now I can transfer it to the front.
Okay.
Okay, so now
Because we
we have
have to make sure.
we have a vice position. Now this is a starting position. So as it moves, we want it to lay down the grease on the
Right.
substrate. So the opening is off to the right here, and I'm trying to do it looking over my shoulder, but I may have to cheat because no one would do this backwards, right? That's
No,
just
you can't. You
it's
can't.
me just
You
trying to.
want to make sure.
Yeah. So let's get that on there, line that up. And I think for demo purposes, I may have cheated a little bit on this pre. Uh, this is going to come around here. There we go. Yeah, there it is. It's getting started there.
Right.
And it has to have enough room then to fit in this space,
Yep.
and then get the
Get it going.
get this threaded in place. So again, I'm a little handicapped here, working over my shoulder, facing the opposite direction of where we would have it. But let me return and kind of demonstrate this process. So swing that out of the way, and now I'm starting to extrude the grease,
Okay.
and it's
And
laying a thin film
right,
on that
just the right
substrate.
amount.
Yep.
Because that would be difficult to control, like on your own manually.
Yeah, it is. And sometimes we've had to in the past, like we don't like have the grease thief analyzer available, and it's like, how do I create that thin film? But it is
Yes.
really important. One of the follow-up tests that we do, and really, if depending on what someone wants to do, they could add more instruments to the mini lab
Right.
because this really puts the grease in a format that it can be used by other tests. So we already talked about one of the Fluid Tech products, right? MPC
Uh-huh.
testing. They also have the ruler.
Yes, they do.
And the ruler is a very small, very narrow neck vial
Yep.
that a solvent and some sand are put in, and we have to
Mhm.
get our sample in there. When we have oil, it's easy. We just use a
Yeah.
little pipette, puts the right amount in, we're good to go. What we're doing here is we are extruding the target of 0.25 grams onto
Yikes.
each of these substrate sections. And so now you have the ability to take this. I want to bring this out the other side here, move my scale for my balance cover,
Yep.
and now I have this extruded.
Ah, I
What
can
we
see
do
it
now,
now.
yep, is we take that section and we peel it
Oh,
off.
that's convenient.
Yep, I'm just going to lay it there. So you can see how that gap is missing there.
Yep.
And now we have this section. And again, we're checking my dexterity here,
Oh, yeah, for sure.
but you can see that, and it's lying as a thin film that puts about 0.25 grams of grease on this.
Yes.
We can always come over here to the scale and check that against the tear value of an empty substrate. But this we can curl right up and put right into the bottle
Ah,
of a ruler vial, and
nice.
it'll stick in the neck. But all you have to do is tap it on the table a few times. It drops right down into the solvent, re-expands, and now instead of having to dissolve a clump of grease,
Yes.
trying to get the additives in solution, you now have a thin film that's evenly distributing it. And we've done a
Goodness.
lot of testing on this, and it's very repeatable. If you're like digging out a clump of grease and trying to get 0.25 grams into one of those vials, not only is
No,
that difficult to do, but that clump makes it harder for the solvent to reach what's inside, right?
it would be. Yes,
Yeah.
definitely.
So we introduced the idea of the theory of sampling in an earlier
Yes, we
conversation
did.
that we had, and it's a technique, really just a whole science or study of ensuring that samples of heterogeneous populations
Yep.
can be representative. And there's a lot of things where it makes sense. I got introduced to it by Mr. Hans Müller from
Yep.
Denmark, doing a lot of work in the wind industry and wanting to take grease samples. With him, we got to write some papers and do some
Mhm.
research with Dr. Kim Esbensen, also from Denmark, and the world's leading expert on the theory of sampling. So what the theory of sampling tells us is that we have to take a sample that is representative by having an even or an equal and non-zero probability of any part of that grease ending up in our sample. So
Yes.
when we take, yeah, this is really wild. Well, first off, people are like, there's a theory of
Yeah.
sampling, right? There's textbooks and courses
Yes,
that
they
you can
are. They
do.
definitely are.
I tell you where multi-million or billion-dollar decisions are based off of that. Where do we site a mine?
Yes.
Okay, we think there's ore here. We're going to build this facility. How much gold is there to extract? How much copper is there to extract? If you don't follow the theory of sampling in
You're not
pulling
gonna get it.
those samples, you will not have a representation, and a
Yep.
lot of money can be spent in the wrong place. So
Yeah.
it can be very important for grease too when we're trying to say, get us the sample, do some analysis, and allow that analysis to represent what's happening in this
Yep.
machine with this grease. So this reorients the sample as it goes through that thin film, and you now have a sample that is compliant with the TOS, the theory of sampling, which is great. So
Perfect.
this can go into a ruler vial. Another one can go into a vial with a lot of the greases we use a combination of heptane and
Hmm.
toluene to get some aromatic, aliphatic, polar,
Yes.
non-polar kind of solvent, properties going. And it's really wild. When we put this into that vial and shake it up, you end up with a clear piece of plastic here
Wow.
because you're, in many cases, almost completely dissolving the grease because
That's
you've made it
perfect.
ideal with that thin film. And
Yeah.
so now you have something that you can run as a RDE spectrometer or maybe even
Right.
ICP. If you want to do analytical ferrography, yes, it's ready for that. But at
Good.
this point, what we've done is we've added this tool to the mini lab in a manual mode here so
Mm-hmm.
that we can get that sample out. Now, what could we tell from that? If you have someone that's doing this on a bunch of samples, you saw me kind of crank down on this handle
Yes.
and you can feel the resistance. And so
Uh-huh.
at a start of some tests, you could do this with the new fresh grease,
Right.
kind of gauge that resistance that you have, and then do it with your samples. And the ones that
Mm.
are easier to extrude or harder to extrude would be your outliers, right? They're
Yes.
hardened or softened greases. So that's what we have right now. What we want to do is the next step is to take this handle away and put a little motor on there, a
Oh.
motor that where we can measure the torque required to extrude it in a given unit of time.
Ah,
And now what you have is what we would refer to as the apparent viscosity of a non-Newtonian fluid.
perfect.
Yeah, because what it requires to do that is you have to evaluate it relative to the shear rate.
Right.
Right? So
Yes.
viscosity of non-Newtonian fluid is a function of the shear rate. So we can control the inputs of the speed of that extrusion, and from that get a sense of how much work that motor's doing, relating
Yep.
that back to the consistency of the grease. So now we've got the color, which is telling us about the condition of the grease's
Uh-huh.
contents, the oxidation of it, contaminants that are there. We've got the metallurgy because
Yes.
we've used the Poseidon ferrocue to figure that out. We have a sense of any changes in its consistency.
Mm-hmm.
And if we wanted to add one more thing to this setup, it would be that nicely portable Fluid Tech ruler device.
Yep.
Because now we just drop this right in, and now we have that fourth component of grease health, which is oxidation.
Yep. Which is very important.
Yeah. So that's what I wanted to share with us today. Just how straightforward this all is, what a
Yes.
small area it's on, the fact that the data is interfacing with,
Mobile.
yeah, smartphone solution. So you can imagine where you could set it up on a little area in your plant. Maybe you've got mobile
Yes.
maintenance going on like wind farms often do,
Uh-huh.
right? Put a couple of these in a van that goes out and services that wind farm, and right on the site, you're finding out which bearings need help,
Yeah.
which have degraded greases, which have accumulated a lot of wear. So
Yes.
you can do something right on the spot. And if you're a laboratory that doesn't yet have the grease thief analyzer and the full slate of tests, you can start with this. You can start by screening your samples, by doing the colorimetry, extruding it out as that thin film, and then having that to put in, dissolve and put in some of the other instruments in your lab, like an FTIR, doing analytical ferrography, doing elemental spectroscopy, all that. So in the lab, at the machine, in the plant, or even in the field, the Grease Thief Mini Lab is the way that any of us, can get started in this field of grease analysis.
And I think it's so perfect because all of the times we spend, especially in the wind industry, don't get me started on that. Nobody wants to go up on those wind turbines and come back down all the time. That's a lot of time,
Yeah.
especially if it's a lot of stairs. But getting it analyzed on site, that helps you so much more in terms of your planning
Yeah.
because planning for these outages, planning for unplanned downtime that you don't want to have, that kind of helps you in terms of, okay, well, I can put this into maintenance, I could take an extra look at this, or, getting that feedback right away. Nothing compares to that.
Yeah. And you make a really good point there, because in the wind industry, there
Oh,
is
yeah.
kind of a way of saying, when we think there's something wrong with a bearing, they're going to do a borescope inspection to kind of
Ah,
validate
yes.
it, right? So let's imagine this: we're making an up tower visit. I even thought, boy, should I put little parachutes in these
Oh, that'd be so
samplers,
cute.
and they could just toss them over the side, and they would float
Yeah.
down to earth, and then the guy in the van would put them here. But whatever, while they're
Yeah.
still there, while they still are on
Yes.
site, and maybe have somebody up tower, that takes
Get
along
it
certain
done.
tools and things. If you've got a bearing, and these guys are working on a lot going through a day, they
Yeah.
might make 6, 8 climbs, 10 climbs. It's like if you find that one of them has an issue, rather than button it all up, go home and have to come back another
Yeah.
day, do the borescope then. Have
Yep.
the data available and say, I did it because the Grease Thief Mini Lab pointed to an issue here, and maybe there's a solution. Maybe they're even having some grease there, and they replenish the grease while they're there. So
Yes.
it's about the delay, right? If we can make decisions on the fly when the service people are there, an
Yes.
immediate turnaround decision, that can change the whole, the whole calculus of how do we maintain these assets.
And it could save so much cost as well because every time you get a guy to go out there or a girl, you
Hmm.
have that's extra time.
Yeah.
That's extra cost involved. That's extra setup. That's extra safety. Because like a safety aspect as well. While they're there, get it done. Get the stuff going because nobody wants to come back the next day and then realize should have done that while I was up there.
Yep, the wind folks, they
Oh yes.
sarcastically call that a bonus climb. Yeah,
Ah
yeah,
yes.
an extra climb. I'm a guy that has done 3 up tower visits
Oh
so
boy.
far, and I say so far like I'm ever going to do it again. I think I'm done. But if you could make that climb and make the most of it while
Yes.
you're there, with the knowledge of what the condition is, that's where this can really be helpful. I have another application, which is the nuclear power industry,
Yes.
where it takes a lot to set up the conditions under which someone is entering a
Yes.
radiation or a contamination area. And if you can't figure out what to do there, a lot of it is they're just holding up grease and saying, "Does that look good to you? Does it look good
Yeah.
to me? What do you
Yeah.
think?" I give it a 5, you know. And they're making multi-million dollar decisions based off of that.
Yeah.
Let's give them some numbers. Let's give
Yes.
them some
Something to
actual
compare
value.
with. Yeah.
Yep. Because you can take the ppm values and you can take up to, say up to 2,000 acceptable, 2,000 to
Right.
5,000, we're going to keep a close eye on it. Above 5,000,
Yeah.
we better be
Do
flushing the
something.
grease or something, or doing an inspection. Same with the colorimetry values. So it
Yep.
gives a criteria that you can make part of these procedures. And we've talked before about, like, for example, you and I have talked about the Chinook helicopters, right?
Yeah.
How we've done a lot of testing in that area, military application. Well,
Yep.
just a few weeks ago, 2 of my employees and I went to a military conference in Pittsburgh, and we met both a Chinook pilot
Nice.
and a National Guardsman who's doing the maintenance.
Good.
And they said, this, having data that
Yep.
goes into the decisions about when do we add grease, when do we replenish grease, and so forth is huge. And they already have that from the study we did in terms of what is the maintenance manual saying about
Yep.
periods of grease replenishment. But think about this. Now they'll be able to take those maintenance procedures that say to some young person who
Yep.
maybe hasn't seen this a lot, say, you know, uh, pull up a sample of grease, and if it looks bad, do these
Yeah.
steps. Well, how will you know it's
What is
bad?
bad?
Right. I mean, it's not just appearance, it's not just color.
Yeah.
And if you say, well, look for shiny flecks, well, you're way past an action level at that.
Yeah.
But with the FerroQ, the Poseidon FerroQ, we can really narrow that down and say this is the expected operating range.
It's like a
Above that,
tolerance.
you
Yep.
take that action, and up to immediately shutting something down or grounding something,
Yes.
whatever the safety implications may be.
Yep.
So yeah, I think is for me, it's always about, I'm going to share with you what we're doing, and then I want to hear
Yeah.
how this can help, right? Because I don't know all the applications out there. I don't know all the
Yep.
circumstances. There might be people in food processing
Yeah.
that are looking at this and say, wow, if we have a drip or a leak somewhere, we can dismiss that as non-consequential, or we can say there's a bearing that's in bad shape, and if
We
we
need to
don't get it
change that
changed
out.
out,
Yeah.
maybe it impacts the quality of that food product or something. So
Yes.
we don't ever want to hear about food recalls, right?
No.
We want to give the tools to the maintenance folks and the operations folks so they can make those database decisions and
Yeah.
continue to supply a good and quality product.
Yes, and I think having the instruments that helps with standardization as well, because the way that I interpret something and the way that you interpret something may be two different ways. Just like the guys going into the nuclear plant, Yeah.
Yeah.
If we
Yeah, I
have
mean,
some numbers, we could work with that.
yeah, I've worked with people who are colorblind, right?
Yes.
And
Yes,
that's
definitely.
a limitation
It
until you
is.
have the eyes that are looking at it for you, and not just saying, "I think it looks like
Yeah.
this." It's saying these are the numerical values that
Yep.
represent that important parameter of that product. So it really just changes the game altogether.
It
What
does.
what I'd like to say, to those who are watching and those that might watch the recording of this, is I'm showing you the first. This is the
Yes.
first Grease Thief GTA Mini that's out there, and we're building now our beta run. So we're looking for some
Nice.
partners. We would like if people see the value here and would like to be a tester of this. We want to gain those insights in the applications. We want to get that
Yep.
feedback. So reach out to me and say, you know what, we don't have a mini lab,
Yep.
but we'd like to try it, or we do have one and we don't have this piece, and we'd like to, put that into our sample stream and be able to get some feedback for it.
Yep.
So, that's kind of a call to action out of this is if you think you're in a position that where you have access to grease samples and you're taking them and you want to test this, reach out to us to be one of our beta
Yep.
testers, because we're going into production with this, and we want to come out with a product that we understand well. We know what the limitations are. We have instructions, operating parameters that are going to fit for everybody, and it really does help to have that input from the end user.
It does because they are the ones using it. So we need to make sure that they can.
Yeah, that's right. Yeah.
Definitely. And I'm so thank you for sharing the first demo with us. You know, we got the inside scoop, inside grease scoop on this one.
Yeah.
So
Any
that's
questions? Did
appreciated.
you see anybody
I didn't see any
on
questions
LinkedIn or
yet.
YouTube or anything?
I saw everybody, like I saw Ahmed is here. He's commented. Bill says it's going to be a great webinar. Of course, I have Gary coming in as well, and Shanewaj, Roy, Thanraj is here too. So a lot of them are just coming in and just they're enjoying the content for sure.
Great.
So no questions just yet, but I feel like there are going to be a lot of follow-up questions because this might have been a lot to digest, and they're like,
Yeah.
"How do I use this?"
Right. Well, I guess the video then goes on to LinkedIn as well, right?
It
So people can
does.
can hit that link and review it at their leisure, and that could be a place where we could collect the questions or the interest in wanting to beta test the units, the
Yeah,
GTA minis here. Let's look for that as some feedback as we go forward. But
yeah,
I think this is what
it's
we
been
wanted to share today,
definitely.
and it didn't fall to pieces trying to demonstrate live. So maybe that says a little bit about the ease
It
of
says a
use of
lot.
of the device that a guy facing backwards was able to
Yes.
actuate the equipment. But again, we really need the feedback, and that's why
Yep.
we're putting it out here. So please reach out to Sanya or I, and
Yep.
or on LinkedIn, what have you. Drop me an email, drop me a message on LinkedIn. Let's get the dialogue going so that we
Yeah.
can bring this forward and make grease analysis. Let it take its place in the industry that it really
Sure.
is equipped to do. Right?
Yes. Because grease analysis is something that we need to get going around the world. So
For
I'm
sure.
glad that we're greasing the wheels of getting that going.
Yeah. And of course, this is you. I think you brought this up at the beginning that this is our first what we're calling Grease Thief Live, as
Yes.
opposed to the Grease Thief Goes to KSA. And
Yeah.
I want to acknowledge and thank Hamza
Yeah.
and all that he has done in encouraging us to start this series, and really have something that the folks in his region can look at and consider, and start to make some steps towards being able to do grease analysis in their part of the
Yes.
world. But you and I decided let's open it up. Let's broaden this out to others as well. So that's the rebranding here as Grease Thief Live, and so that's our September, and
I
we'll
do
get
have
some.
actually I do have some questions. Hamza just alerted me that we had some questions on YouTube. He's asking, what is the relevancy and accuracy of the results between using a mini lab and an actual lab? That's
Okay.
interesting.
Yeah, great question. So what I'll say is that the FerroQ and the colorimeter are being used in the full lab, right? So
Okay.
that is the technology. So we're just picking two of them that can easily be done in the field, but when it gets to a laboratory, they're doing that as well. Then the other piece, with the GTA Mini and the extrusion die, there's some real differences here. So one of the main ones is that the temperature is not regulated for the GTA Mini. For the grease
Mm,
thief analyzer, it is a temperature regulated environment at 30 degrees Celsius. So the baselines are 30 degrees Celsius,
right.
the sample is, and that's where our values in terms of gram force are reported for that parameter that is part of ASTM
Yes.
D7918. So this would not meet D7918. It's meant to be a screening process. But what we would do is extrude at room temperature the baseline
Right.
grease and then extrude at the same temperature without a variation there, the sample that we want to evaluate. I would say right now it's very subjective, right? We're just using the operator's feedback as they're extruding it to say, hey, this one is a lot, thicker, a lot runnier, what have you. Whereas the grease thief analyzer, we're getting
The
percentage
actual
change of
values.
values relative to the baseline, and it is temperature controlled. But as we do this, we're going to learn more. And the next step I'm really excited about, which is to put that stepper motor on there and to
Yes.
actually have, that relationship between load and torque, and see, we might be able to get some proportionality constants going between this
Sure.
and that. But for now, it's just meant like, hey, it's about the same amount of force. The fresh grease, it's good to go. If it doesn't, then we're going to send it on to the lab to get that detailed analysis. So that was a great question.
Yeah, and I think Linda Perry actually asked a little bit of follow up to what you're talking about. She asked if the future torque or apparent viscosity will correlate to rheology.
That is an excellent question as well.
Yeah,
The thing about rheology is that we are measuring the flow characteristics as we change the shear force, right? So
right.
we're exploiting that characteristic of grease. A rheometer, which is a very expensive and sensitive lab piece
Yeah,
of equipment, looks at a lot of different manifestations of that flow behavior. What we're hoping is that this becomes a screening tool, and we actually, Linda, would take the backup by doing some samples here and screening them, and then sending them all to a rheometer and seeing what level do you say there's not enough change here. We're just going to, this is a good sample. The machine's in
yeah.
good shape versus the ones that would need some follow up either with die extrusion or further on to rheology. But a lot of people ask me, I'm so glad she asked how do they compare, because a lot of people say, well, can you correlate it to cone penetration? And the,
Ah,
and the answer is no. I mean, cone penetration is a static test, and it's really just used uh, for new greases to put it in one of multiple categories, NLGI grades, for aligning to machine applications. It really doesn't measure in
yeah.
service or dynamic characteristics of the grease. So in that regard, Linda, it's a dynamic test. It's a dynamic variable shear input test where we're measuring the response to it in the same way that rheology does. It's less precise, but it might get to a point where we can use this to decide when it's worthwhile to do that rheological testing.
All right, because we have some other questions just coming in here
All right.
on LinkedIn. We have Bill, he's asking about how much does the system cost? Well, I think that
Oh,
depends on what instruments you're actually gonna use.
yeah, so you can find these two items on our website, greasethief.com, and together somewhere in the US $15,000 range, you're set up with these two instruments. For this new instrument, like I said, it's in beta testing. We
Right.
expect to have two versions of it, possibly three. Like I've thought, if it becomes difficult to use the motor torque or
Right.
motor response, we may have to put a load cell in it to measure that,
Uh-huh.
like we do with the grease thief analyzer. But this is really too new to be priced at this point. What I will say is this manual version, which allows you to prepare these, it's going to be very comparable and in line with the pricing of the other instruments here. Because
Yeah.
it's a very simple design, that we've developed here. But to actually see, which iteration you're purchasing, like you
Yes,
say, the full manual versus the stepper motor and so forth, that's going to make a difference on price. But what I
for
would say to
sure.
Bill right now is it's zero if you're going to be in a position to beta test it with us and get some of the first ones we're making. So.
Mm. Bill, you may want to take him up on that. Um, so we also have a question from Klinsman, and he's asking, will the mini lab be able to analyze deviation from a particular grease consistency?
Okay. For this device.
Yes.
Okay. So right now, what I've demonstrated today is really just a lab technician's perceptive feel, and that's, that varies from person to person that we've talked about. But we may find that, this is a nice, more obvious way of differentiating that. And I imagine that an operator over a period of time will become pretty adept at knowing which samples are outliers here.
Oh, yeah.
But, it's not until you get either a load cell in here to measure that response or control the input of how quickly it's moving and shearing the grease that will really have, those kind of capabilities that are comparable to the grease thief analyzer.
I have one more question for you, and it's from our friend in Singapore, Raj. She's asking, how can we check ICP elemental analysis for used grease, and is there any ASTM check method for the on-site analysis of that one?
Yeah, so there's not for ICP. And as those who have that in their lab know, it's a little
Yeah.
touchy when it comes to your non-traditional liquids, things that are too
Yeah.
thick, or things that because we have to make that that injection into the plasma, and it's a little tricky. So I've had some folks that have been doing that. It is not part of an ASTM standard at this point. I think what we can do is, kind of say this is how we prep it, quantitatively keep track of the volume, the mass and the volume that's being produced, and then use that to make an adjustment or a normalization to the ppm values that we get out of a calibrated ICP.
Ah,
But I think some greases are really challenging to get
yes.
into a complete dissolved liquid state, and there are some challenges in using that. Not so much for RDE. So for those labs that are using RDE, it's pretty straightforward. The rotating disc picks up this fluid, very repeatable kind of test, and I can share our practice with the RDE with those who are interested.
All right. One more question.
Okay.
Jose is actually asking us from Bureau Veritas. Is it possible to automate the grease color analyzer?
Yeah, that's a good question, because you can see how
Yes.
it is still kind of a manual process. It's pretty streamlined, but someone has to be there at that unit. So here's what we're doing at MRG Labs, Jose. We're using robotics and automation for that
Right.
process. And right now we're looking at two formats of the grease. One is in the grease thief itself, so that we have an optical camera system or a vision system where we are taking that grease sample and then rotating it to create a panorama of the grease through this little window in
Ah,
the grease thief, and using that to screen samples for color changes. So
oh,
we're going to look at, yeah, it's pretty cool, because we're going to go,
nice.
we're going to have that relative to what the new grease is, and
Right.
create little images that are representative of that, but also create a histogram of the color distribution. So if you
Okay.
see different colors in the grease, and those of us that test grease, it sometimes shows up. It's like, wait, I can actually see some light
Yes.
colored grease and some green, and there's a little red over here. But we're going to use that as a screening test. And right now, yeah, we do have a solution for that. That's automated to handle the grease thief. That's doing the ferro-Q, that's doing the weighing or the
Yep.
massing of the sample, and then also doing that vision system on color, and from those measurements, screening out our samples that way. So yeah, it's an automation solution. We're using it here in the lab, and if that's of interest, let us know, and we can work on a system for you too.
Sounds good. I just have one more question from Hamza,
Yep.
and he's asking, how many percent of samples can the mini lab actually, perform? out of if you have samples for the entire plant.
Yeah, so that comes down to resources and so forth.
Yes.
How many different assets you have, how often you're sampling them, and so forth. And when he said percentage, Sanya, do you think he was asking about how many then are judged to need to go on to a laboratory for more detailed analysis? Is that
Um,
the nature of the question,
I
or?
feel like it's trying to gauge how many samples can the mini lab process.
Oh, okay. Yeah.
Yeah.
Well, you saw me. If I wasn't stopping to explain everything, you could see that it's a few seconds on the ferro-Q,
Yep.
maybe closer to a minute and a half on colorimetry. And then this extrusion, which is, a relative measurement, you saw my extruding that out.
Yep.
So I think it's the potential is there to have this with a whole lineup of grease samples, knocking them out in less than 5 minutes per sample.
Ah, that's pretty effective.
Yeah.
It's pretty
So maybe,
efficient.
yeah. So yeah, you're talking about a dozen, a dozen an hour or something like
Yeah.
that. Yep.
All right.
And that also answers the question about the automation, right?
Yes.
So we're doing, thousands of samples for certain applications. Some are
Yep.
wind, some are food processing, some are robotics, but a lot in the locomotive industry,
Yep.
and we're setting them up in racks and
Mm,
having a robotic system kind of run through them and screening them. And then when you get the 7, 8, 9% that are outliers, you just
right.
grab them on the way out and do the more detailed analysis. And so that
Perfect.
cycle is just a few minutes, and it's on to the next sample.
All right. I think that sort of clears up all our questions for today.
Great.
But I think we did good. Like this was
Okay.
so helpful for me as well in terms of I know I now have a small area that I could put some equipment in if I
Yeah,
wanted
we
to.
talked about the countries out there. You could
Yeah,
be
I
the
could be
first one in the
Trinidad Tobago.
Caribbean, right?
Why not?
Yes. Well, thank you very much.
You're
It's
most
yeah,
welcome.
we'll let people go and grab their lunch
Yeah.
or head to bed or
Yes.
wherever they are in the world, and
Yeah.
we'll get together again in October, right?
Yes, definitely. Look out for the invites, and we will be seeing you all soon. Thank you so much for sharing all your knowledge with us, Rich. Bye.
Bye. Thank you.